There we go. Should be live now over on the YouTubes. Yeah, it looks like we're going. There we are. So here's the thing. So first off, I got to make everything bigger. We just got to scale up. So these screws aren't gonna help us. But also if I suppress that feature, okay, that's not gonna. Okay, so we're gonna have to go like all the way back. Like we need to be much larger. Rocket diameter. This needs to be like 100 or 100 or like 200. That's funny. That is very funny. Okay. I need like a fin can length, ultimately. I think we had that in like 100 millimeters or something. Oh wait, no, that was fine. What is this sketch? All right, let's rename it. Fin sketch. I think it is this here. I think it was the plane creation. Yeah, that is fin can length. Let's edit the fin sketch. Let's just do fin can length. We're gonna make this let's see here. Let's make a parameter. We'll call it fin width. We'll go with 50 for now. We'll do fin can length divided by fin width. Oh wait, no. That's not right. Fin can length minus fin width. Yeah. No, you know, no. Let's we'll do fin can length times 2 divided by 3. We'll go 2/3 of the way up. Yeah. That looks a little better. Alright, so where did I sketch the fins? Let's edit this sketch to just, you know, do that. Actually, let's edit that sketch again. I'll edit the sketch. Is this a good profile? It feels... I mean, it's gonna get longer. As we go on. Let's just make this 400. And we'll make this 250. We're absolutely going to be printing in parts. Rename. Forward fin. Sketch. Rename rear fin sketch. Can I move this? Huh? Yeah, like that. We are good. Although actually, I think I need to. Move that up. Oops, nope. Okay. There we go. So now I've got things cut in the middle. Still thinking like we probably need to just like make it even larger. Also, yeah, that looks better. That looks better. Okay, so I still think I just need to make this larger and larger. We're getting chunky. We're getting chunky. Okay, so then the fin can length go 150. Fin width we go up to 75. We're gonna go length, the initial sketch length. Let's just do like 800. Rocket length. Times 3 divided by 4. Honestly, you know what? That's not a bad way to go. That looks too chonky. But it's like, it's the same for both of them. Oh, if I change the fin can length. Okay, that looks a little bit better. Also, yeah, these fins are definitely going to need to print separately. Undefined error. Great, thanks. They're very thin at the moment. Wait, hold on. We have the fin width. Wait. I think that's wrong. That should really be wing or fin. I'm trying to think of it like wings. Oh, you know what? I'll call it fin thickness. Oh my gosh. Okay, it's way too big. I understand that. But that's funny. That's better. Just so it stops complaining. Ha! Okay, that's kind of funny. Let's set the opacity here to like 20%. Set this to like 40. At some point, I feel like I did something to punch that hole all the way through. I just don't know where it is. Hmm. Hmm. Maybe I need to like hollow out that section, or hollow that out a bit. All right, at least the hope here is that you'll be able to like reach in and be able to push out the motor retainer from that side. Although there's kind of a different problem here now. And honestly, kind of everything after this just doesn't work. Like I think we just kind of need to redesign that whole thing. Because we're not able to interface from the outside at this point. Because what would be cool is to be able to kind of have like that whole like skirt section in the back there. All right. Let's try this. Let's create a sketch. Cancel that. Hold on. Motor sled retainer diameter. Right now that's set to 36. Inner diameter plus 20. Oh wait, edit the sketch. Inner diameter plus 20 plus 20. Leaving myself plenty of margin here. So we I think this was 100. I thought. Why? We don't even need the fin can. We can just measure. Okay, it's 74. I have an idea. What if you screw the motor retainer into the aft end of the rocket? That could actually be a really cool idea. It'd be toolless. That could actually be a really cool way to do it. Yeah, so you just kind of screw it in from the back. I think I need to redo this though. Partially. Maybe. One of these was offset face. Edit this feature. Pin can length minus motor thread retainer length plus 10 times -1. That's not what I thought was going to happen at all. Actually, I have a better idea for how to do this. Let's just offset this face. Just go all the way like that. Wait, no. think I want to come all the way up to here. Hey, Misadventures in Astro, welcome on in. He says, my virgin eyes! How you doing? So we are here to raunch some lockets. And I've come up with a better idea for how to retain the motor in the rocket. And my idea is that this retainer, I should just put threads on it and make it screw into the fin can. And then kind of make like, it's hard to see from here, but essentially make it so that you can like, you know, do it from like the rear end of the rocket. So you don't need to like push it from the other side. You can just unscrew it. So essentially kind of like this. Actually, I wanna redo that, but divided by 2. So at least this way, it's like directly pushing on. Like on stuff, you can easily unscrew it. And honestly, it might make even more sense to make this motor retainer longer at this point. Actually, what I should have done is I should have made the motor retainer a separate part. Yeah. So that's the whole, that was the whole purpose of making like this like tab thing here. Well, so that after you launch it, you just pull the tabs out, push the motor out, and then you pop a new one in its place. And then you screw it back into the rocket and you go and launch again. That's at least the idea. Like I said, I probably should have made the motor retainer its own component. Auto disk fusion. Let's see if you can make it a new component. Open the file, right-click the body in the browser tree, and select Create Components from Bodies. Now add like 32 more motors and 6 stages. Create components from bodies. Okay, where did that go? Wait, is that a... No, I wanted a new document. Oh, essentially you have to export it and then like re-import it. And then export. I mean, I guess it's this. Yeah. Motor retainer. Okay. Okay, I might need to export it again. Now let's see what happens if I come in here now. Why do okay. Why do I not have... So, misadventures. Earlier today, I was watching a couple videos from Copenhagen Suborbitals, and I saw that they were using stainless steel for their like pressure vessel and their whatnot. Since they're doing like pressure fed rockets, I think for one of them it's pressure fed. And because they did stainless steel and welded it all, they tested the pressure vessel to failure, and it held like 1,300 psi, which is way more than like anyone would need. I can work with that. Well, it was also funny because it like ballooned out and like stretched as well. It's like, yeah, like if I do 500 psi, well under, like you can make a... Yeah, they have some margin. They absolutely have margin. But like I was just thinking, I was like, if I go back to my my editor calculator thing here, and I put that stuff back in, like, if I've got 500, hold on, what is it? Bar to PSI. We got 500. That's 34 bar. And that would be your tank pressure. And so you probably want at least 2, a factor of 2, probably 3. So you could go down to 10 or 20 bar on this thing. right? So like if I went to like 20 bar, it could become a 61 kilonewton rocket engine. Which if we, you know, make it slightly wider, but then increase the length. Whee! Obviously, we're not going to make like a 60-foot rocket or whatever that is. So what is that? So 400 centimeters is 13 feet. And look, this, and they were using 2mm thick stainless steel. So it's like 50 kilometers. That's not bad. Although I will say that is a ridiculous thrust to weight ratio. So like, oh, this version doesn't have my dry mass budget. Hold on, let me see if I can download that. I have another version that has like a dry mass budget. Where is it? Okay, it's 4.1. Okay, it is 4.1. Okay. Whatever. Alright, yeah, here we got additional payload. So, yeah, if we do, let's just say 10 bar. And 400. Like, it's just, it's a ridiculous amount of room to play. Like, even if we went up to like 200 kilograms of extra payload. Hey, OG John Stamos says, hey, this is cool. Welcome on in. How are you doing? So we're just talking a little bit of rocket science at the moment. With a little predictor thing that I made. Obviously, it's, you know, self-made. It's not going to be, you know, worth much, but it's fun to think about. Though, his adventures, this in centimeters is 36 feet. So, we go 36 feet, you know, we got a space shot. Though at that point, might as well just make it thicker. Let's do it. Yeah, if only we had the funding and the know-how. Yeah, like, so here's what, like, if we just increase the diameter to what is 2 feet? Like a 2-foot diameter. That's about 61 centimeters. We can bring it down to about a body length of 370 maybe. So 370 is 12 feet. So if you go 2 foot by 12 foot, so 2 foot wide by 12 feet tall, just for the body, then, you know, and obviously, you know, like I said, if you're adding on 200 kilograms of other stuff, you know, whether that's parachutes or thrust vector control, who knows. But also, you need a shit ton. Carmen line, here we go. You also need a shit ton of fuel. But anyways. I mean, 2 foot wide gets you a decent amount of room for anything you want. You know? But anyways. It's AI generated, probably wrong. So we're gonna treat it as such. See, that's you know, that's a 10-year plan. Also, I need to turn a fan on. It is way too hot in here. There we go. Don't think the size is that off, honestly. I mean, it assumes a lot of things, right? Like, it assumes that the engine doesn't weigh a lot. Like, we don't know what the engine would weigh. We also don't have the weight of any, like, stringers or potential, like, anything in the rocket to help the pressure vessel. You know, structural. Any landing or recovery gear. Actually, what did it say the dry mass was going to be? It said dry mass would be 384 kilograms. Like, the smallest rockets that made it to Carmen Line that I know of are like 12 feet tall minimum. Gotcha. Yeah, because like the other thing is we'd want thrust vector control. Although, if we're doing a propulsive landing, we need to aim higher. We need to aim higher. We'd also need something like grid fins for aerodynamic control and stability on return. So that's going to eat into the mass budget. Any servos. And that's how it just gets taller and taller. I wanna offset this face. I wanna add like 40 millimeters. Something that we can build a like the ability to, you know, screw it into here. I don't know how far I'm... Oh, there we go. Fin can. I wonder if you can control the body enough to body flop and has some downrange control, just add chutes and don't worry about retro propulsion. Well, yes. Oh, you know what? When I came back to this, so it says the dry mass up here. That dry mass includes the 200 additional payload. So but also you'd need something to control the body flop. The fins, yeah. Yeah, here, this is actually kind of what I'm looking for. Might be a fun way, fun way to work on things for the model size. Just add some flips. So, so misadventures. One of the things that like if I could do everything that I want to do. Here's the way that I would work towards this. Is I start with getting this working, learning CAD, designing a rocket, learning, you know, all that. As I'm doing this, I start building thrust vector control, start designing it, start figuring out how to arrange it such that, you know, such that you can, you know, even with a model rocket, control it on ascent. Working on a connection interface system now. Yes, James Factor, because all of this was too small for my printer to do reliably. So we need to go bigger. We need to go bigger. So we've upped the size, and I'm changing how we interface it. So rather than it being like a almost kind of like a slide fit that it was, or the grub screws, we've removed the grub screws, and now instead I'm gonna make the motor retainer its own, like make that screw into the rocket. Instead, because those threads will be bigger. And hopefully printable. Oh, that's the engine port. Gotcha. I thought that was going to be the interface between body sections. No. Yeah. Because I also have a very old printer, and it kind of sucks, and I have a new throne goal for a new 3D printer. If anyone wants to help that, help the space program. So anyways, misadventures. What I was saying is, start with model rockets. Start with thrust vector control, like learn it, the electronics, all that stuff. Start working towards higher power. When you're doing some fluid simulations of your rocket body, well, that'll be after we do we learn thrust vector control and start getting into high power. That's down the line. After we do high power, we start learning some stuff like fluid simulations and, you know, CFD, which I think Autodesk Fusion does. You know, once we start getting good enough with some of this, we start learning, we start designing the engine. Can I make a suggestion for your throne goal? Sure. I'm guessing you're gonna say don't do a Bamboo Labs printer, is my guess. The P2S is only $30 more. Really? Let me see here. Wish list. Alright, I removed that. Now I have an X1C, I'd be a hypocrite. Bamboo P2S. You know, it's interesting because Throne doesn't list it directly. But I can add things that aren't on there specifically. Wait, but the sale ends tomorrow. Apparently. So, unless someone really is willing to just, you know, drop the money tonight. I think it'll be $100 difference. Drop it like it's hot. I'd check on that in a few days. It could be that clever Chinese marketing of buy now or miss out. Well, the thing is that, I mean, you're not wrong. But the thing is that other things like B&H say it ends tomorrow night. But you might be right. But regardless, yeah, I mean, also true. Or check Micro Centers. We do have a Micro Center near here. Let me make sure it's not gonna dox it. If I wasn't married with 3 little kids, I'd buy it for you. But printers don't put food on my table. Hey, welcome on in, Mo. See, Mo's willing to help the space program. He wants to get rockets launched. I mean, that is true. There are chocolate printers. You can actually 3D print chocolate into something. Yeah, chocolate rockets. It melts after it flies. It just, hey, we get that chocolate rain. Sign me up for that printer. I'm gonna shoot you a DM on Discord if that's okay. Absolutely, go for it. What? Alright, well,
chocolate sexy daddy. All right? Vinny is chocolate sexy daddy. There you go.
Yeah, exactly. Exactly. But then, you know, the other thing, though, is that there are also some 3D printers that can do a version of that can they can print a form of filament that contains carbon fiber. Which, if we're 3D printing stuff, maybe that carbon fiber strength is worthwhile. Yes, I accepted it, Dream Spectre. I saw. Let's see. Can afford to help. Yeah, I mean, the other thing too, Dream Spectre, is I think what I just need to do is I need to get my I need to run my 3D printer like super slowly. Like it's an old Monoprice / Prusa 3 that, you know, it doesn't have an enclosure. I don't have desiccant packets. I'm sure the filament has you know, soaked up a whole bunch of humidity. There's all these kinds of things that you should do for 3D printers. And who knows what shape that nozzle is in. It's probably in a terrible shape right now. That is good to know. I will let you know if I need anything. All right, so now let's try this. Let's take this and let's create the red. I don't want that. Don't want full length. I do want it modeled. Misadventures. Alright. I need like large threads here. That is not large. Wait, that just increased the size. Oops. Also, FYI, we do have both telescopes out. We are currently waiting for darkness. So one is working on the big mosaic project. The other, I've started a mosaic for the Dark Shark Nebula to do a 2x1. Yeah, there's a little bit of dust. No, not that face. There we go. You had some really strong winds last night. I'm sorry to hear that. It does not like that. Isometric. Had decent scene from the heat dome. Alright. So hypothetically, oh, that'll actually be even better. I can print it like that. Just nice big threads. Yeah, that's... Well, that being said, this might be too long. Because even... the idea was you'd be able to, like, poke your finger down in here. $114 millimeters. That's some threads for sure. That's the goal. Millimeters to inch. 4 inches. Yeah, that might be too long. Actually, maybe not. It might not be. Considering the length of the motor. Better have material with high temp handling. Yeah. Okay, so... yeah, so that's... I think you'd be able to stick a finger down in there, but that's... I still think that's kind of too long. Yeah, I think this. Edit feature. Let's do... Yeah, but we want to edit this now because we don't want to go that far with the threads. We kind of really only need like that much. See, that's why I need a new printer so that I can print in carbon fiber. I need to offset that face. So basically there. And then actually let's Let's actually take this face and offset it. Bring it in. Because I want to do a combine. I want to do a cut, but keep both tools. Wait. That just did a joint. That was supposed to do a cut. So now we've got internal threads that directly match the motor retainer. And honestly, I think that's a much better way of doing it. What is that to that? That is... well, that to... No. Okay, so that's one. That's two. All right, 348 millimeters. I don't know if I could print that. All right. Here's another thing we got to do. We got to get some a leading edge chamfer. There we go. Oh wait, I should have done this on the upper body fin. Edit feature. 4 edges. These are also going to go 5. So. Wait, change parameters. Did I have a thickness? I did. So what I could just do is I can edit this feature and I can do fin thickness. Oops, I didn't do it for all of them. There. So if I modify the fin thickness, so let's say I put that to 10 millimeters, now they're still automatically chamfered. All right, so the question now is, so I need to cut out the actually how do we want the mid bodies to connect? Do we want it to be slip fit, or do we want to actually like screw it in? Because we could potentially screw it into the fin can. The only thing that would not be a slip fit would be the top. Would be the upper body, because that needs to pop out. It might be easy, yeah. It just requires our threads to be I mean, slip fit, if it blows, maybe not all parts are goners. Yeah, but it's also 3D printing, you know? What is the diameter of this edge? 180. And then the outer one is 200. So it's 20 millimeters of so 3/4 of an inch. That's actually a decent amount for threads. Yes, you probably only need 3, but what I kind of like is the ability, so what I want is the ability to make it modular enough that like you can change out the motor retainer for like, let's say an A engine versus a D engine. You can put in what you want, and then based on how many or what size engine, you could have varying levels of mid body, you know? So you could just screw in more of them. D's rockets. So yeah, that's kind of the goal, is to be able to do that, you know? Make it modular enough. Okay, so what we need to do, this was 180 millimeters. We need to create a sketch. $80. Do I have a variable that's 180? I do. If you can figure out a way to make solid rockets have some have some trust control. The DoD will pay you handsomely. I mean, that was Joe Barnard's YouTube channel for like 7 years. Until he finally landed a model rocket. Was everything he was trying to do was thrust control on a you know, Yeah, yes, he was using ST's, or actually it wasn't ST's rockets. He was using model rocket motors, all solids, to land that rocket. Yeah, it was entirely solids. Yeah, this video here.
With Amiga Auto Insurance.
All right, come on. So where's the actual like flight here?
Next, I'm Joe Barnard. May your skies be blue and your winds be low.
So yeah, this. Wait, was that the actual flight? Yes. So like, this is the history of all of his rockets.
Okay, that was clearer than the last one. Where are my legs? Why aren't the legs out?
I just realized that my So yeah, all solids. All right, before copyright comes for me. Diameter minus 20. Actually, this should just be like rocket wall. No, cancel that. Inner diameter. There we go. So finish that sketch. So we need to extrude that. It's going to be a cut going that way. Now we've got our hollow tube. Also, we don't need these grub screws anymore.
Yes.
We're not using them anymore. Alright, so now... Actually, we might want to offset that face. Hey! Hogan, welcome on in. How you doing? No, cancel that. How you doing? Let's turn off the mid body. He says, howdy, how are things? Good, we are doing some CAD design of a model rocket a reusable and modular model rocket, mind you, that when finished will look like a SpaceX Starship. So the idea is that you'll be able to swap out reusable and modular are two good things. Yeah. So the idea is that there's this like motor retainer in the back that when everything is said and done, I'll make it for multiple Estes rocket sizes, so A, B, C, and D. And then all you have to do is, you know, unscrew this little retainer, pop out an old motor, put in a new one, screw it back in, and you're basically ready to relaunch. And then, based on the motor size that you use, there's going to be a varying number of mid bodies, which are going to screw in, so you can change the length. And then the top upper body is what will pop off, and you know that's where you'll attach the parachute between the two and all that. So that is the idea. And so today, the thing that we did, or that we started off the stream with, was this whole thing was way too small, and my 3D printer does not do that well. So I had to go bigger and adjust this design here because it was not going to be able to hold it well. And in fact, this may even still be a problem. This this motor retainer here. It's possible that this might be too small of a tolerance, and I might have to rethink this. Like, maybe I need to do like a screw design or something. I don't know. Like you screw it into the retainer. I don't know. But we'll find out. We'll find out. So right now what we're working on is the mid body. So the the mid body, we have the ring, and I'm gonna make it screw into the fin can. But that means that I need to make the I need to make I need to make sure that there's enough gap here for this to screw into, if that makes sense. So ultimately, I think what I need to do is I need to take this face and bring it out more. I've been wanting to get a 3D printer, but that's one more thing to learn how to use. So I'll just stick to calling my Miller 252 wire feed welder my 3D printer. I print metal. That is one way to do it. Alright, so that should give us enough space. But that also means that we need to adjust this face now. So, you know, I've got a 3D printer, but mine, man, is just, it's just old and it does not do well. So we've, you know, I had just put a throne goal on up on, or I just put a new thing on throne for a 3D printer, but it seems like they're either expensive or it might be worth waiting, but we shall see. Let's do 40 millimeters. All right. So with that, now we can bring the mid body back, and let's actually create some thread on it. We're not going to go full length, and we are going to model it. That's not what we wanted. Time to get some VC funding. I wanted this from the other side. There we go. Let's do 20 millimeters. Oh wait, I need to, no, those are
Misadventures in Astro just shared 100 bits towards Snacky's education. I want 10% shares for my angel investor status.
Angel investor right there. 100 bits. Oh, see, this is interesting though. So when I change, okay, to the moon. All right, I gotta delete these threads. So what I need to do is I actually need to make it offset and shrink it down. Because the threads are affecting the whole thing. So if I choose smaller threads, it shrinks this whole diameter, which is not what I want. What is the best way to do this? No. What is the best way to do this? I think I know. Wait. So hold on, what were these threads again? They're trapezoidal threads. Okay. All right, I think I know how to do this. So we're gonna create a sketch. It's gonna be 200 millimeters, and then we're gonna go 190 millimeters. So we're gonna finish that sketch. Now we're going to extrude this. It's going to be a cut. I think we said 20 millimeters. There we go. So now I can do threads on this face. Got a WebSocket error. Yeah, I think that's something with like StreamerBot or something. Is it? Well, that is not exactly. Maybe this will work. So, with that being said, what is the distance between that and that? 20 centimeters. Okay, so if I take this body, oh, excuse me. So now if I do a combine, theoretically, we now have a can that we can screw into. But here's the thing, is I need to make these same threads on the other end of this, so that we can screw multiple of them in. So I need to take this whole mid body and copy it. So now I need to do a combine. And theoretically, you can now stack all of these. Like, you can stack as many as you want. We go to the upper body now, which is way too large. Which we need to split. So this plane Let's do it like here. Okay, so now this upper body, we can split the body. Splitting tool. Nope, that's not right. There's that. There we go. Okay. Oh, I just thought of something. That's dangerous. While we can screw these in, there's no way to easily slip fit into a screw there. So I need like an adapter for like the end. I have a feeling I know where you're going with it. Or we just make it as big as the threads, and you just ignore the threads. You know what I'm saying? Like, we just make it this diameter. Because that's what the threads go that far anyways, you know? I think it'll work. Also, I'd love to ungroup this. I don't know what isolate does. Alright, so let's create a sketch again. On this plane. Do a circle. I'll be rocket diameter. And then this will be tin can wall inner diameter. And this will be a cut. Just do that much. But now we move this, theoretically, we can just, you know, plop it together. So like that. And hence we have a rocket. Actually, I just thought of something. I forgot about tolerances. Should we be tipping dollar bills for that movement there? Yeah, absolutely. I forgot about tolerances. And I think I did, and I think I forgot about tolerance for some of the other stuff too. Like the threads. Wait, no. The threads used... The threads should be fine. Because that was full cutout from geometry. So that should be fine. The only slip fit is this here. So we want to add that tolerance. So now the question is the motor retainer gonna print well? That I don't know. Here's hoping it does. But we've got potentially a reusable rocket. Well, you can export the retainer as its own STL and C. Yes, we can do that. In fact, maybe we should. Alright, let me just make sure that this doesn't show something it shouldn't. Alright, come on, Kira. I forget that the controls are different. Probably print it like this. Actually, with the size of this, that's actually not that bad. So let's slice it. Oh, so it looks like we're still waiting 14 minutes. I mean, those are pretty big threads. Wait, why is there something weird here? You could honestly probably block those lower supports. I'm sure that even your printer can bridge the top of the compliant leg prongs. Save a wee bit of time and reduce cleanup. See, that's a whole bunch of stuff that I don't know how to do. Are you talking about these ones here? These ones right here? Yeah, I don't know how to do that. What the hell is a banana split? Oh, support blocker. Let's just do that. Is that right? Did I do it? I don't know if I did it. Oh, you have to select the model. I don't know what I'm doing here. I'm selecting the model. Go back to prepare. Oh, whoops. I see. You're saying like that. I think. You'll want to click the top of the legs. Like that. All right, and then just slice it. Well, oops. All right, let's see if maybe that's what I needed to do. Gotta say that was very funny. Hey, Havoc, welcome on in. Coming in with that raid.
School of Sharks from Harvard's and 14 just raided with 2 ups.
How's it going, Havoc? What were you up to tonight? Were you playing some Rocket League? Thank you for trusting me with your community. Bringing in everyone, all the party people. What were you up to? What were you doing? For those of you that are new here, I am NinjaGloppy, headmaster here at the School of Sharks, where normally we play Rocket League. But today we're joining the League of Rockets, and we are making a literal rocket. We are designing a 3D printable, modular, reusable rocket. I was playing this game called The Incident at the Galley House. Interesting. Interesting. Yep, I am confused. It worked correctly for me. Well. I mean, I'm sure it's fine. It came out today, pretty fun so far, but I gotta get ready for bed. Have a good one, Poppy. Well, thank you again for bringing over the party people and stopping in, and I hope you get some good rest because you are not required to stay. Go and take care of yourself. Does the blocker extend to fully cover the red overhangs on those areas towards the center? I don't know. Okay, so maybe it is also what I'm using for supports. Like, maybe we need to change it. You think maybe we got to do it on the inside too? Look at that. You can scale the blockers to overlap that rather than placing more. Are you sure about that? Let's try it. Yeah, that's what I was like, maybe it's support settings, but if we can scale them, then it might be easier to just make like 1 or 2 of them. Oops. That should do it. Oh, excuse me. Might want to uncheck you. Actually, well, we'll see. I actually kind of want that because that should extend inside too. Theoretically. All right. Okay, calling it your Kira is Fubar. All right, support. Support structure. Let's try tree. I didn't know I was calling upon Cthulhu here. But what I will say is we got rid of these ones. So, you know, that's good. Yeah. Six of one, half dozen of the other. I'm just looking to see if there's like any other options that might be good for us. But I'm kind of getting a bit overwhelmed with all the options here, so we'll leave it at that, and it'll take 3 days to print. Make sure The use towers is disabled. Oh boy, 3 days. I support horizontal expansion. Set to 0. None of offset applied to all support polygons in each layer. Positive values can smooth out the support areas and result in more sturdy support. You're saying set it to 0. The expansion can override blockers. You know, I am a little worried that... Yeah. I'm a little worried this might get thin and snap, but it might not matter. Right. Alright, I am curious. If I take the fin can and I save that out. Yep, that's a big fin can. Actually, it might be easier to print this way. It's been so long since I used an older printer, I forgot how privileged I am with the ones I have. I know, right? I think that's too big for my print volume. I don't know that I can print it. The retainer would be about a 45... Well, okay, so to be fair, I do have this set to a super slow print speed of like 10 millimeters. Or 5 millimeters a second. To try and get the absolute best quality out of this terrible printer. Well, thank you for lurking. Every little bit helps. Doggo left the game. They are waiting in the lobby. So if I move this out of here, bring this in. Yeah, I think the No, I understand. That's what I mean by privilege, though. Yeah, I know. Like, my printer is literally, like... I think I bought it in 2012. 14 years ago. Like, the price I paid then would get me a much better print today. For the same price. Because I think I paid about $300 back then. Right. Exactly. Actually, I just thought of something. I keep doing the wrong thing here. Maybe we should fillet these. For strength. Nope. Might be worth it to fill it. Like for strength. Also, I don't know if anyone has heard, but Nerduino is on the path towards partner. He is pushing for partner, so every little bit that you can help him out would be appreciated. He is awesome, friend of the channel. We love him dearly. Started with a MakerBot Replicator 2 in 2013, moved to an Ender 3 in 2018, tinkered heavily with it until I got your X1C. There we go, even a little bit of filleting will help. Now, it's not true to life for an actual SpaceX Starship, but this is modeling. And that's all, excluding my fun times playing with Delta printers. Deltas are still and will always be your favorite printers. Why is that? What about them makes them stick out to you so much? We just love the kinematics. Oh, like these kind of ones? I mean, I get it, but because yeah. All of them are out of stock. Seems like this is the only one. They're just mesmerizing to watch. Yes. Sure. I don't know. I'm... $600mm. You know, for printing a rocket, that would actually be pretty cool. 600mm. My first Delta was a little itty bitty monoprice mini Delta, then moved to an Anycubic Predator, and now I have an FL Sun V400. You know, Dream Spectre, maybe it would be worth it to have you try printing these to see if they even mesh well, you know? Mini Delta had a print volume of a soda can, literally. Because let's see here. If we do a measurement, and we do a measurement from there to there. That was 348. That's bigger than 280. Can you print something that wide? 348 millimeters. Now that being said, you could go corner to corner and rotate it 45 degrees and get more space. Yeah, that's why it's like, this is kind of big. As a 400 millimeter print bed. I'm very jealous. But that's also one dimension, right? So if you had to, you could go side to side. X1 carbon is only 257. See, this is why I was saying that the fins should probably be separate. I keep doing the wrong thing. Cancel that. I didn't do a sketch. Yeah. I mean, I could potentially reduce it. Hold on. Let's change it. So the rocket diameter is 200 millimeters. So if I bring that down to 180. Oh, that messes up a whole bunch of stuff. Like the threading. So, yeah, so if you do the fins separately, then, then all of this becomes easier. I'm curious to see how much filament the fin can itself would take to print at full size. Alright, well, let's do this. Let's remove that. Alright, well, it won't let me. Because my printer's too small. Alright. Well, my goal of me 3D printing this has hit a snag. Unless we redesign it to make it smaller. Or we take the fins off. Yeah, let me do that real quick. Let's put that over there. So I tried to reduce space by not having the whole like inside be like solid. Although I just thought of something. We could potentially make a booster stage. We could make a starship, or not a starship, a super heavy booster that just slip fits into the bottom of this. What did you say the fin tip-to-tip measurement was again? I think it was 384 millimeters. Yeah, 348. Or, no, I said 84. 348, sorry. What is weird with the STL export then, because it's larger than my V400's bed. Huh. We'll save as mesh. It's STL binary. Unit type millimeter. Never mind, I lied. The V400 is 300 in diameter and 410 high. So again, can you rotate it 45 degrees and fit it? Or no? Not on the V400, the bed is a circle. Oh. So, yeah, we gotta take the, we gotta take the fins off. Oh, hey. We are starting to take some photos. You could almost fit it at 45 degrees. Oh no. So just to show you guys what we are imaging right now. So we have two telescopes out on the deck. And once this loads, I'll show you. So we are imaging the Dark Shark Nebula, which you can see right here. Looks like a shark with an open mouth. So we are doing a mosaic, so you can see that there are two images, or two panels. Technically fits on the X1 carbon, but there's an exclusion zone. Yeah, so we gotta make it smaller. Which that's gonna mess up a whole bunch of things. And then the other one here is doing the Seder region. I think even 80% scale would be printable. Yes, but you can't just scale it because that's gonna mess with the motor retainer. So the mini rig, as I call it, is imaging from here all the way over to like here in one huge mosaic covering this entire section of the sky. It's a 15 panel mosaic, like something like this, I think. So we got the Seder region, we got the Crescent Nebula. There's the North America Nebula, the Pelican Nebula, and then you can't see it off here, but there's the Clamshell Nebula as well. And the Forsaken Nebula. So those are the two things that we are working on. But it sounds like we need to adjust the outer diameter of the rocket. Rocket diameter. I'm gonna drop it down to 150. 10 warnings. What's the first warning? What's being combined? Why is this a problem? I mean, some of the problem with this is that I have such a long history that that it would mess up a lot of things downstream. I think. It could almost be easier to like restart the fin can, you know? Undefined error. Great, thanks. Alright, so if we do this now, measure that to that. So we now have tip to tip 298 millimeters. Instead of 348. Although, that being said, this is without the fins being attached. So, really, it'd be 200 millimeters for the diameter. I managed to make it fit, and I'm waiting on the slice. It's not liking the supports. Yeah. Problem is, I don't know what's being combined here. Or why is it an issue? Is that all I had to do is just go into it and hit OK? apparently. All right, well, I think what I'm gonna have to do is model a whole bunch of this stuff separately. Now that I kind of know what I'm doing, that I have an idea on how to do it, it's a bit easier. So it'd use over a kilogram of filament. Yeah. So yeah, really what I need to do is I need to just redo all of this, I think. Because the timeline's all messed up. In fact, let's just redo this. Let's get it back to where I had exported it. That could be fixed with a redesign of the bottom of the fin can. You make it an inverted cone at 45 degrees. No support will be needed there at all. Alright. So I think ultimately what I'm going to do is, because we are out of time for tonight, I'm going to keep this as a reference and make a version 2. Or maybe even copy it and then, I don't know, something. Be able to copy out the components. You know, like the motor retainer. Now that I know what I'm doing with that, I could make just that as a part, and then export that to you know, what am I trying to say? I could make that its own part and then use an assembly and bring things together, and that'll clean up the timeline for a lot of this stuff. But ultimately I think we've made progress, even if it's too wide right now. But I also like the idea of modeling a super heavy and having a bunch of boosters in there. That I think would be fun too. And actually, now that I think about it, with these fin cans, we should also, or not the fin cans, like the mid bodies, I should maybe make one that could do like payload deployment. Like take like a, you know, like some Raspberry Pi, or not even, like an Arduino even, you know, an ESP32, such that, you know, if you add like an accelerometer, a battery, and then it detects, you know, a reduction in acceleration from stage 1, it could then E-match fire its own boost to continue. Make a true 2-stage rocket. hot stage it. Actually, it'd be kind of funny if I made like the hot stage like whatever, and like just like metal print that so that like you could actually hot stage this. That'd be kind of funny. But in any case, it is time that we say goodnight. Unfortunately, I do have to go to work in the morning, and I need to go to bed at some point. So, the first thing that we are going to do is say goodnight to the YouTubers. So, goodnight, YouTube. Bye.